And the other 0 over 0 condition involves trigonometric functions. The rules of the special trigonometric limits are derived from L'Hopital's rules, which we will learn in chapter 3. So for now, just know them as rules. So the rule says whenever limit as x approaches to 0, in all of the rules we have limit as x approaches to 0, the ratio of sine function or to x function, or x to sine function, or the ratio of tan function to an x function, or x function to a tan function, or the ratio of sine to sine function, or tan to tan function, or the ratio of sine to tan, or tan to sine function, then the result is the coefficient, the ratio of the coefficients. The coefficient at the top is a, coefficient at the bottom is b. So it's always the coefficient of x's. When we have 0 over 0 condition, we apply these rules. All right, it's always a over b. The same doesn't go for cosine function. For cosine, we can't say it's cosine ax over bx, so it's a over b. It is different. We don't have cosine over x function. We don't have such rule. The rule is 1 minus cosine x over b of x, bx. 1 minus cosine something x over bx. It doesn't matter what the angle is. We have 1 minus. We don't have cosine over bx. 1 minus cosine over bx. All right. So the result is not a over b. Result is 0. It is just for cosine. So the last one is different. The rest is all the same. Okay. Sometimes you have sine, sometimes tan, sometimes together. Sometimes only sine, sometimes only tan, sometimes they are together. So the rule is always coefficient of x's. So let's take a look at some examples. The first one, evaluate the limits. The first thing we need to do whenever we have limit question is doing direct substitution. Make sure that we have 0 over 0 case, because sometimes when we substitute the number that the x is approaching, we get a real number. We don't have a different condition, so we can find the answer right away. So since we don't know what type of question, what type of limit we have, we should try. We always try, substitute, plug in, and see what's going on in this question. Okay, let's see what's going on in this question. When we plug in 0 for x, so what is sine 0? It is 0. What is 5 times 0? It's also 0. So it is 0 over 0 case. The rule is pretty simple. Then we take the coefficient of x's. The coefficient of x at the top is 1. At the bottom is 5. It's 1 over 5. Pretty simple. Huh? Here I have another question, involves cosine. Remember the cosine rule. It wasn't only cosine over an x function. It was 1 minus cosine over an x function. So here I have 1 minus cosine x over x. But there is an extra number here. It's disturbing me. I want to get rid of this first. So let's move it out in front. We can do that, right? It's one of the properties of limits. We can bring the scalar product in front. So we can rewrite this as 3 times limit as x approaches to 0 of 1 minus cosine x over x. Now I got my cosine rule here. So this is exactly what I have here in the last rule, whose answer is 0. So when this is 0, 3 multiplied by 0, the answer is 0. Okay, let's move on. Another simple question. Plug 0 first. Sine 0 is 0. Sine 0 is also 0. So 0 over 0 case, which needs to use these rules. According to the rule, we just focus on the coefficient of x's, which are 2 at the top, and 3 at the bottom. So 2 over 3. Okay, these are first type of questions involving these rules. Another type of question is that there will be combination of these rules together in one question. For example, this is an exercise question and asked twice in Wazari. It's cosine times tan over x. So there are two different trigonometric functions divided by x, but we don't have such rule, right? Our rules all involve either sine, the ratio of sine and tan, or alone. It doesn't involve cosine and tan together. So we have to do something. We should rewrite it then. Without rewriting this function, we can't answer the question. So let's simplify a bit. How do you simplify? So what I'm going to do with this x in denominator? Am I going to use this x with cosine or with tan? For which one I can use it? Can I use it for cosine? Suppose I do. Do I have such rule? Cosine x over x. Let's look at the last rule. It doesn't involve cosine x over x. It involves 1 minus cosine x over x. So I can't benefit x with cosine here. I can't use x with cosine. I should use x with tan. So when you rewrite it, write it as limit as x approaches to 0 of cosine alone multiplied by limit as x approaches to 0 of tangent x over x. So I broke this up into two different limits. Remember, I can do that in addition, subtraction, multiplication, division. It's like distributing the idea of limit, right? It's one of the properties. So I broke this up into two different limits. So the first part, when I substitute 0 for x, what happens? What is cosine 0? It's 1, right? Times, when you insert 0 for x, 0 over 0 case. So these rules apply. So take the ratio of the coefficients of x's. Coefficient of x at the top is 1. At the bottom is also 1. 1 times 1 will be 1. So the answer to this question is 1. Okay. So this complicated question becomes really easy at the end. Another question. There's sine squared, but we didn't learn such thing. But when we rewrite this function, we can use one of the rules that we already studied. So when you do direct substitution, what do you get at first? It is 0 over 0. So after we make sure that 0 over 0, we apply the rules. So limit as x approaches to 0 of sine squared is actually sine times sine, right? Sine times limit as x approaches to 0 of sine. What about x? For which sine function should I use x? Does it matter? Actually, it doesn't. They're both same. So use x with one of the sine functions. So when you insert 0 for x here, the first part, what is the answer? Sine 0 is 0. Multiplied by, what about limit as x approach to 0 of sine 0 over 0, which is 0 over 0 case, which needs to use these rules that tells us to take the coefficients of x's that are 1 at the top, 1 at the bottom. So 0 times 1, which gives you 0. Okay. Here in these two questions, we solve the question as writing and by breaking it up into two by using multiplication. Here in this following question, there's subtraction, so we will break this up into two by subtracting. It's like, let's say, a minus b divided by c. How do you rewrite this fraction? You can write this as a over c minus b over c. So we will use the same idea here by rewriting this. we rewrite this because when you insert 0 for x, you will see it is 0 over 0. In order to use one of the rules that we studied, we will break this up into two first. So let's do that. Limit as x approaches to 0 of the first term at the top, 2x, the bottom is 5x, minus limit as x approaches to 0 of 3 tangent x divided by 5x. Okay, it's like distributing the idea of limit, one of the properties that we studied. So what is limit here in the first part? In the first part, when I insert 0, it's 0 over 0 case. Remember, we should simplify in such cases. When you simplify x's, you're left with 2 over 5. The first part is 2 over 5. Minus, what about the second part? Second part is also 0 over 0 case, involving tan and an x function. The coefficient of x here is 1, but there is also a coefficient of tangent, so do not ignore this. We take the coefficient of x as an angle, the coefficient of the angle. We also take the coefficient of the function. There is a coefficient of function as well. So 3 divided by coefficient of x at the bottom is 5. So here I have 2 over 5 minus 3 over 5, which is negative 1 over 5. Okay, there is another question which is really nice. This is in the book and asked in Wazari. I have cosine and sine together. Unfortunately, I don't have such rule. Do I have sine and cosine together in any of the rules? No, I don't. So I need rewriting. Let's try to rewrite it because it is when you insert 0. 1 minus 1 is 0. Sine 0 is 0. 0 over 0 case. So we should rewrite it. So let's revise the rules first. So what rule do you know about cosine? About cosine, I know that 1 minus cosine x over x, limit as x approaches to 0, is 0. But I don't have this here. And about sine, being in denominator, limit as x approaches to 0 of, if sine is in denominator, I need x in numerator, so that I take the coefficients, it's 1. So I know this and this rule. How can I rewrite my function so that I can use these two rules? Okay, how can I turn this into these two? So let's think about it. How do I rewrite it? Limit as x approaches to 0 of 1 minus cosine x over sine x. So the way of solving these type of questions is dividing top and bottom by x. Okay, this is a different type. For this kind of questions, we will apply this method. We will divide top and bottom by x. So remember, adding something to both sides or dividing something with the both sides with the same thing doesn't change anything. We still keep the balance, so we can do this. There's no harm. So what can you say about this now? Distribute the idea of limit. Limit as x approaches to 0 of 1 minus cosine x over x divided by limit as x approaches to 0 of sine x over x. Now you can answer the question easily. What is the value of this? It is 0. What is the value of that? That's 1, as we studied here in the rule. So 0 over 1 is 0. Okay. The same question is asked 2021 ministry question in the second trial. Option D. Option D is same as this question. In option D, we have the same question with the same answer. Question was asking which one is true. So we just solved this question. This one is true. Okay. What about option C? What's wrong with option C? With the 0 over 0 case, when you insert 0, so you should take the coefficients. What are the coefficients of x's? 3 at the top, 2 at the bottom. Not 2 over 3, 3 over 2. Okay, that's what's wrong this with this option. I'm not explaining A and B. We studied these two before. You try by yourself. Now, one last question. Another ministry question requires using the same idea. For such complicated questions, whenever you have 0 over 0, then you divide everything by x. Everything by x. Okay, that's the way, like we did here in study guide question. Okay, let's start solving. Limit as x approach to 0 of, let me write this question by distributing limit. Limit as x approach to 0 of, okay, at the top 3x squared over x minus sine 2x over x. At the bottom 2x over x minus sine 3x over x. So I divided everything by x. Okay, this is the way, just like question 7, this study guide question. So now we can answer the question. Let me write these limits 2 different times. Write limit at the top, limit at the bottom. Here also there is limit. Oh, let me write it again. It doesn't look good. This was my intention at first, actually. I was going to write limit for every term. Limit as x approaches to 0 of 3x squared over x minus limit as x approaches to 0 of sine 2x over x divided by limit as x approaches to 0 of 2x over x and minus limit as x approaches to 0 of 3x over x. So divide everything by x and distribute the limit. I skipped a step here. At first I was supposed to divide everything by x and then distribute the limit. I skipped a step. You can understand. Okay, now let's do the simplification. X and one of the x's will go. It is 3x only. When you insert 0 for x, 3 times 0, 0 at the top, minus. There is 0 over 0 case, which means take the ratio of the coefficients of x's, 2 over 1, divided by, x's will cancel, only 2 remains, minus, x's will cancel, only 3 remain. There is sine x. I forgot sine x. I am forgetful this video. X's won't cancel, of course. Here we take the coefficient of x's. Okay, the coefficients are 3 at the top, 1 at the bottom. So at the top I see negative 2, at the bottom negative, excuse me, there is 0 here, 0 minus 2, negative 2 here, 2 minus 3, negative 1, which is 2. All right. So this was a complicated question, but when you know the way, which is this unique way, dividing everything by x, you can answer the question easily.